Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper, where I'm going to teach you finally how to create your first Grasshopper component from scratch, from complete scratch. So in the previous videos, we have seen how to install Visual Studio, install the extensions that generate templates, and create a project template for a Grasshopper plugin and link the output of that project dynamically to Rhino loading and uploading the version of the compiled plugin immediately. All right. So, and for that, we use this sample code, this boilerplate that came with the template generator. All right. So we're going to put this aside for the time being. And what I would like to do now is I would like to teach you how to create a Grasshopper component in this plugin from scratch. What are the parts that we need to take a look at? Where do we write the code? And how do we turn that into an actual component? So let's go step by step. The first thing that I would like to do is I would like to create a new empty template for a Grasshopper component. The way I'm going to do that is I'm going to go right click in the main pcam Grasshopper plugin. I'm going to close this down. I'm going to right click here, click add, and I'm going to add a new item to my project. You can see that if you were to open this from scratch, you would land here in this list of the possible items that you can add to a project. That can be files, classes, components, and a bunch of stuff. And if I keep scrolling down, you will see that at some point, you will have the option of adding an empty Grasshopper component for Rhino 7 or whatever, which at the end of the day is just a C# file, as you can see in the name editor. But it's a C# file that is going to come pre-populated with a few overrides and a few sections that will make adding code much easier and much faster. So I'm going to start with a very simple example where I'm going to create a component that adds two numbers, like the simplest thing ever. So I'm going to call this add numbers component. When I write Grasshopper plugins, I like adding component to whatever is a component, right? So I'm going to create this file called add numbers component. I'm going to create this, and you can see that this new file shows up on my project, and that already has a bunch of code here that does absolutely nothing. So the question that we're going to start with is, what is a Grasshopper component in the first place? Well, a Grasshopper component is basically any code that we write subclassing this Grasshopper component abstract class that the software, the SDK for Grasshopper gives us as, I don't want to use the word template again in this case. It's sort of a template as well, but it's basically a class that forces us when we subclass it to add a few overrides and a few methods that force us to customize the behavior of this one component that we create. But by doing this, the original Grasshopper component class has a lot of functionality inside of itself that we don't need to mess with, which takes care of taking what we're going to write and putting it in the right way and making a box out of it and attaching an icon and all those things that are necessary, or the infrastructure to make this component show up on the screen and work when we plug in wires, etc., etc. So what we basically do when we create components is that we create instances of subclassing the Grasshopper component class. And actually, if you press F12, if you press F12, you can go to a sort of high-level description of all the methods and all the stuff that is already pre-populated and all the code that makes these components work, which we don't need to mess with. But because we have generated this with a template, it's actually really nice because it already gives us empty categories of what's important for us to customize in this component. So the first thing that I would like to highlight is that this is a class, just like any other classes that we have worked with in object-oriented programming. And if you're not familiar with object-oriented programming, I really recommend you check out our videos on object-oriented programming. Cards will be popping up here in the corner or in the description of this video. And but it's basically instances that are generated by the Grasshopper engine for your component. So every time you drop a new component, a new instance of this numbers component will be generated. The class needs to have a constructor. The constructor is the first part that the template gives us here. And you can see that the constructor has a few things. It basically takes 5 strings which determine the name of the component, its description, and where it's going to show up on the screen. All right, on the Grasshopper. So let's see. For example, I'm going to keep add numbers. I'm going to remove the component part because this is going to be the name that is going to show up when on my tab when I drop down. All right. The nickname is going to be add nums, for example, because it's typically the version of the name but a bit shorter. The description is going to be add two numbers together, for example. And then the category and the subcategory is where in my Grasshopper this component should show up. If, for example, I were to say here maths and operators, for example, then my component will show up in the default Grasshopper native maths and operators categories. Because I'm creating my own plugin, which is going to be new and it's going to have its own tab and its own everything, I probably don't want to do this. What I probably want to do is, first of all, come up with a name for my plugin. So I'm going to call this pcamp. So pcamp is going to be the name of the plugin. And then the name of the category inside of the plugin is going to be operators. I'm going to keep these operators, but I will eventually transition to categories that match this prototype that we have been developing in previous videos in this series. Okay, so I'm going to keep this as operators. I would have the option of adding custom code when the component is created, but for this one, I don't need to do any of this. There's nothing I need to prepare before adding two numbers. So I'm going to leave this empty. Now, because this is code, remember when we were working in C# scripting, when we wanted to work with the inputs, what we did was we placed the C# script component and then we click add inputs, remove inputs, and we right clicked on this must be a boolean, this must be a double, etc., etc. So that we were able to customize the types that were coming into the component, and also if it was an item, a list, a tree, etc., etc. That we cannot do manually with an UI in here. So we have, though, a way to do the same thing, but do it with code instead of doing it with the UI. That is what these two functions, register input parameters and register output parameters, what these are meant to do. These are functions that I use to define what is going to go into the component and what types and what data structures, and what is going to come out of this component. And the way that I'm going to do that is by using this argument that the Grasshopper engine gives to the component every time it initializes a new component. That is called the P manager or the parameter manager. Think of this as, I don't know, a worker that is given to your component, and then you can tell the worker, hey, can you please add an input of a number? Can you please add an input of the type vector? Can you please do this? And then the worker will take care of somehow placing those inputs and giving them the right types on your Grasshopper component. Okay, of sorts. So what does that mean? The P manager object contains a lot of functionality that I can use to create those parameters. So for example, if I say P manager and I type dot, you can see the whole list of add angle, add arc, add boolean, add box, add circle. You can already see all the really cool, all the functions that give me the access to add stuff to the input. And basically they are typed. So because I want to add two numbers, the way I'm going to do that is I'm going to scroll, I'm going to find add. You see I have add integers, but I don't want integers because I want to be able to add numbers with decimal part. In this case, the way Grasshopper calls this is not a double or a float, it's just add number. So I'm going to add a number. And I'm going to open parentheses, and you can see that I have 3 overloads. I'm going to scroll to the longest one, all right? And I'm going to scroll to this one. And what this one says is that this component, this function needs 5 arguments in order to work. It needs the name of the input, it needs a nickname, so a shorter version, the description of this input, and the access to the data structure, whether if it's an item, a list of the data tree. You've seen this already in the C# scripting, and whether if I actually want to add a default value, or if I don't want to use that, then I can just stick to the overload that doesn't have that parameter, and there's no default parameter. So let's start with the simple. Add name, I'm going to call, for example, number A, all right? And the nickname is going to just be A, because it's in Grasshopper, typically nicknames for inputs and outputs are just a capital letter or two. It's just a convention. The description is first value to add, for example. And then when it comes to access, the way we define the access is by using a numerator. If you don't know what an enumerator is, please see the video that is going to pop up as a card here in the corner or as a link in the description of this video. So there is the Grasshopper gives us the Grasshopper parameter access enumerator that when I click dot, I can choose between 3 types: item, list, or tree. Does this sound familiar to you? Doesn't this look exactly like that right-click, choose tree, choose list that we did when inputting data in C# scripting? It's the exact same thing. So for this one, I'm going to choose item, okay? And then I could choose to have a last default value. So I could say, for example, the default value is going to be 0. If no one gives me anything, then just 0. All right, so that was the first one. I want to add a second one, so I'm going to call this one, I'm going to copy paste, call this one B. This is going to be the second value to add. And then it's also going to be an item, and it's also going to have the value of 0 as default. Beautiful. My component already has 2 inputs. Then for the output parameters, it's going to be the exact same thing. So I also have a P manager object that I can use to add a number parameter, which is going to be the result, and the nickname is going to be R, and the description is going to be addition result, for example. And then parameter access is also going to be of the type item. And this one doesn't get any default value. Okay, so we have inputs and outputs, and now how do we connect them? Where do we actually write the code? Where do we write the code is in this third method that we need to override, which is called solving instance. All right, solving instance is very, very similar to the run script method that we had inside C# script components. What this does is that it retrieves the data from the inputs, and then here you can write the code to work with that data, mesh it up together, and do whatever result. Okay. Now, how does this work? The way this works is it's very Grasshopper like. I don't know how to say this, but it has a very specific pattern. Let's say to how do you have to write the code to retrieve data from the inputs and to output data to the outputs. The way that works is that you are also given this thing called the data object as an argument. Again, think of this as a worker of sorts that is given to the method and that you can use to access some functionality from the component. In this case, data access is going to be our middle person between our code and retrieving data from the inputs and getting data from the outputs. What that means is that we don't have a variable. By doing this, we don't really have a variable anywhere that we can use to read the value of number 1 or number B or whatever that is. There's no such thing. We just added these 2 inputs, but we don't have, where do I access those inputs? Where do I access those inputs is by using da.getData. So with this, you can, the da object has a function called getData that allows us to retrieve information from the inputs. And what it needs is, first of all, it needs an index. So which one of the inputs am I reading from? So you can see that because I have 2 inputs, the first one will be called 0 and the second one will be called 1. So I want to get data for the first one, And this component also, what it does is it doesn't really return that data, because that data could have multiple types. So what it does is it asks us for a reference variable that it can place that data inside of. Okay? Think of this as the out keyword that we use sometimes when we call methods. So what we need now, I'm going to stop here for a second. What we need now is actually a variable that the DA object can take data from the 0 input and place it in that variable. For that, I'm going to then define a variable beforehand. I'm going to call this A, and I'm going to initialize it to the value of 0, for example. And then here, what I'm going to say is, whatever data you get from the input 0, can you please place it on variable A? All right? That's one thing. And then similarly, I'm going to do the same thing for B. I'm going to create a variable B, and then I'm going to say da.getData, and whatever is coming in from the index, from the parameter in index 1, can you please place it in the variable B that I just created? And with that, what I have now is the variable A and B containing the information that is coming as an input. All right? So I'm going to say define placeholder variables, and then load values from inputs into those variables. All right? So now, and then once I have the input values, now I can actually just the code that actually does the work. So here I can just now write my algorithm, whatever the fantastic code that is going to be running inside of this component. So here is going to be something like the sum is going to be equal A plus B. All right? Beautiful. Now I have the operation, and now I need to find a way to actually output that result from the component. The way this works is that I also use the DA object, and I say DA, but instead of get, what I want to do now is set the data. All right? And set data is going to be a function that is going to take the index of the output parameter. We only have one, so that's going to be 0. And then the object, the variable that contains the data that we want to output through that output. So that's going to be, in this case, the variable sum. Okay? So yeah, this is a little weird. It's not perhaps what we would have expected, but it's kind of how Grasshopper works internally. You always have to handle yourself how to retrieve the input data, turn it into variables that you can use, and then how to, once you have written your algorithm, how to output that through the component. All right? Beautiful. I'm going to save this, and then as I run my code, hopefully, let's cross our fingers, we should be able to see that component show up in Grasshopper. Okay? So let's do that. Come on, come on. And then, wait. Have you seen this? I have a new P all the way here. It's called pcamp. It's my library. And it has this one category called operators and one component called add numbers. Oh my God, I can't believe this. Choo-hoo. And then it takes A is the first value to add, B is the second value to add, and it has default values, and R is the result of the addition. God, can you believe this? Can you please try? Okay, so I'm going to add this together. I'm going to add this, and I'm going to plug here a panel. Sorry, I'm going to plug here a panel. And boom! Oh my God! Seriously! Alrighty. Beautiful. How awesome was that? Huh? Our first component that adds two numbers together. Now, we're going to do a few more examples of simple components, create a vector, add two vectors together, all that stuff. We're going to do it very soon in the forthcoming videos. But before we do that, I would actually like to go back and finish some of the work that we've done here. I'm going to close this. I'm going to close Rhino. And then something that I would like to do is, first of all, something that is very common when retrieving data is that sometimes you actually don't want the component to work or to operate unless there has been some data fed into the component at the input. The way we can do that is because if you look closer to the definition of the getData function, the getData function doesn't return the value. What it returns is a Boolean that says whether if data was fetched from the input or not. And then that data either gets saved in this variable or not. But the return type of getData is an actual Boolean. So with that, we can actually write things such as, for example, if not get data, so if we did not get any data from this input, then stop the execution of solver instance. We just do not want to solve anything. The algorithm is not going to run. Or if we did not get any data at all from the second input, again, I also want to return. I do not want to do anything. And if you actually look at the code that David Rotten put together as a template, this is the method, this is the pattern that is most common for loading inputs. Here you can see that the component loaded a plain, two numbers, and an integer. You can see that those were a plain parameter, number parameter, and integer with some defaults, a plain in the world X, 1, 10, 10, etc. The output was a curve. And then here the component, what it did was it retrieved data for these three variables that were stored, and it did some checks, it created the spiral, and then it output the spiral through the one single output that this component has. Okay, so you can see that the structure is very, very similar to what we've done. It's just a bit more complex. We will see in this series much more complex examples, don't worry. Another thing that I wanted to take a look is the other stuff that comes with the template of the component. First of all, we have the possibility of adding an icon to this component so that it doesn't show this white transparent thing. We're going to do that in the next video. I'm going to teach you how to load an icon and paste it here in the component. Then there's this thing called the component GUID, or the global unique identifier. Every component needs to have this string of numbers that basically is their ID number. And this is useful because it allows Grasshopper to make sure that it has some kind of unique identifier between different types of components, so that you can actually have components that have the same name, the same input, etc., but internally they're different. And Grasshopper does not confuse. If we create components using the template generator, like I did for this one, the template generator will give us automatically a global unique identifier that is new. So, and very likely it will not be, there's actually a very, very small chance that this will randomly generate something that has already been generated before. But if you do it from scratch, if you create this file from scratch, you will be the one who has to provide a global unique identifier. What this is important is to keep in mind that if I were to say, you know what, instead of using the here, add, new item, whatever, I'm just going to copy and paste this component and create a new version that is very similar, just has a different name, etc. If you forget to change the Grasshopper, the GUID, because this component has the same ID as this one, Grasshopper will complain and it will not let you execute either one of them. So if you do copy pasting, just make sure that you generate a new GUID. And there's actually, you can just Google GUI generator, like give me whatever, and then you can just generate them. It's a very, very common thing to do. Okay, that's the second thing. And the last thing is there is this thing that is called exposure of the components. I'm not sure that we're going to see it yet, but basically when you have, how can I say this? Let me actually run right now so that you can see. I think I'm getting into the weeds of. Basically, there is this additional parameter called the exposure that we can use to you see how these components are divided into this block here, this second block here, this third block here, this fourth block here. And so we can kind of bucket components according to whatever logic we want to implement. That can be done by adding an override. So for example, and that's going to be exposure. So we can just add here. If you type override and you type exposure, it already gives you the autocomplete of what is the exposure level that you want for this component. And what I can do is I can say exposure dot, grasshopper exposure dot, and it's an enumerator, and I can say primary, secondary, third, fourth, whatever, or I can actually hide the component. If I use hidden, then the component will exist, but it will not show up. Why is that important? Well, for example, this component, the sample one that came with the template, right now it's showing up and it's in my Grasshopper with the curves and stuff, whatever. I may not want to delete this code because I may want to read the comments and have like inspiration on how things are, but I may actually don't want it to show on Grasshopper. So something that I can do is I can change this from primary, change it to hidden, for example. Okay? And if I do that and I run and I execute Rhino now, oh, there was a build error. What happened? What is the error? I'm going to go to error list. Oh, I don't know what the error is. No, what is the error? Ah, yeah, because I still have the two Iniquiten. I still have this file that, yes. So I'm going to run this again. There were two classes with the same name, so it was not running. And you can see that now I run Grasshopper. I create, and I go to curves, primitives, and it's not here anymore. Okay, it's actually loaded, it's somewhere internally, but it's hidden. It's not available for us to use. Okay, beautiful. And last but not least, I don't know if you have seen any of my source code ever, but I actually like doing this thing. I actually like code. Sometimes in Visual Studio is very hard to read, and when you're seeing the same thing over and over again, you can't distinguish anymore. I like doing this thing where I like big ass headers that have like the name of what I'm looking at. I typically use this technique of using ASCII characters. So for example, let's say that I go here and I plug as comments, I plug this really large letter that says this file is a file that adds 2 numbers, okay? So, and now I scroll down and I can see what the code is. But for me, I find this in the long run when I'm working with like many files and mix matching things, I find this idea of adding big ASCII letters very useful for me. So I recommend that you also do it if you want. You can choose your own type of ASCII letter. I use ANSI Shadow, and I use this online editor. I actually do this most often in Visual Studio Code. I have a plugin that does this. So I invite you to consider doing this because in the long run, it gets things less confusing. All right. Beautiful. With this was our first component from scratch. Again, we're going to do more simple examples of adding things together, creating simple vectors, etc., like we did in our C# prototype. We're going to do an exercise very soon, but I would like the next video to show you how to attach icons to the components that we create. So let's take a look at that in the next video. And in the meantime, maybe like this video, say hi, subscribe to the channel, and all those things if you're enjoying the content that we're doing and if you feel called to do it. Thank you very much and see you on the next video. Bye bye.